No. Hello YouTube, welcome back to my class. So in this topic, basically, or in this video, we're going to discuss about chemical reaction and equation. It's a very interesting thing for class 10th CBSE science, particularly chemistry, right? So the first chapter basically chemical reactions and equations. The story basically begins with an interesting thing which you might already came across in class 6th or 7th, that is physical change and chemical change. Physical changes means the matter changes form but not chemical identity. That means there will be no new substance will be formed. That is called physical change. Example will be like melting of ice. This is your one of the best example for physical change. Otherwise, tearing of paper, right? Now coming to chemical changes. A chemical changes or maybe chemical reaction occurs, but there is no new substance will not be formed. Particularly new substance will be formed. That means a chemical changes will be occur. Whenever there is a new substance will be formed, that is called chemical changes. Example will be like burning. Clear? Or maybe you can say roasting of iron. Clear? Or maybe any biological death, that is also belongs to chemical changes. So without wasting any time, let's begin the chapter. Now coming to the first subtopic, that is our chemical reaction. Chemical reaction means whenever chemical change occurs, there must be a reaction takes place. That reaction is called as chemical reaction. Clear? Now, which substances are going to take part in the chemical reaction? They will be called as your reactants. There is a new term has been arrived. That means whenever we talk about any substance are going to take part in the chemical reaction, they will be called as reactants. The substance which is going to be produced, that is called products. For example, let's say I have taken magnesium plus oxygen. It gives rise to magnesium oxide, right? So far magnesium and oxygen, they are present left hand side of this particular arrow mark, and this arrow mark actually defines the reaction proceeds or not. And the right hand side, who will be there, that will be our products. So far you might have understood about the concept, what is reactants and what are products. Clear? Okay. Now what must be the signs or maybe a kind of indication that a chemical reaction will take place or not, whether it is evolution of gas or change in temperature or formation of a precipitate or change in color or change in smell or even odor or production of light or sound. If any of the processes or either one of the processes is actually occurring during a chemical reaction, then that will be a signature, that will be an indication of chemical reaction. There must be some interesting curiosity in your brain that what should be necessary things to do a chemical reaction. Exactly, these are the necessary things for a chemical reaction. I hope this is clear. Understood? Okay. Next, now coming to chemical equations. A chemical equations or chemical equation symbolically represents a chemical reaction by using the formulas and the symbols. And the reactants are on the left side and the products on the right side. And the balanced equation that is crucial for satisfying the law of conservation of mass. I hope this is clear. So we are talking about chemical equations, right? Chemical equation means it's a symbolic representation of a chemical reaction by using some kind of formulas and symbols. As I already mentioned, like magnesium, instead of magnesium, simply I can write Mg. Instead of oxygen, simply I can write O2. Instead of magnesium oxide, simply I can write MgO. So this is the simplest way to write any chemical reaction. So that's why this will be called as chemical reaction, but particularly chemical equation. I hope this is clear. And your student, always remember that every chemical equation or every chemical reaction should be balanced. Sir, what is the meaning of balance? There must be a question. If you want to know why a chemical equation need to be balanced, that means an interesting story is there. in class 9th, you already read about it. One law was there, law of conservation of a mass, and which was given by Antoine Lavoisier. Antoine Lavoisier. According to this law, every atom should be equal in the reactant side according to the product side. That means the number of atoms in the reactant side should be equal to the product sides. That means here one magnesium, two oxygen, one oxygen. But here this equation is completely unbalanced. It needs to be balanced. So that we have to balance this equation to satisfy this law of conservation of mass. Clear? During every chemical reaction, the mass of reactants, that is left hand side, should be equal to the mass of products. I hope this is clear. Okay. Now coming to writing a chemical equation. What are the techniques or the procedure authentically to write a chemical equation? Whenever you are going to write something, you must have known to know about the concept that anything should be left hand side means there should be the reactants. If anything present on the right side, there should be your products. If more than one products, they should be represented by the plus sign. Similarly, if there are more reactants, they also represent by the plus sign. Already the same example I am going to represent to you. Let's say magnesium, oxygen, two reactants, so that's why plus sign should be there. And here it is only one product, that's why there is no plus or no minus. If more than one product, there should be plus sign. Clear? And certain things are there, like the arrowhead points towards the products. This arrow particularly, it shows the direction of the reaction, in which way the reaction is basically proceeds. And certain conditions are like that. Physical state, S stands for solid, L stands for liquid, G stands for gas, AQ stands for aqueous. Aqueous means water solution, that is in chemistry called AQ. And there are two specific things you must remember: the upward arrow mark and the downward arrow mark. Upward arrow mark represents releasing of gas, and the downward arrow mark represents formation of a precipitate. I hope this is clear. Let's take one or two examples so that you will easily understand the concept even better. Let's say I am taking zinc plus HCl. Clear? Gives rise to zinc chloride plus H2. And here hydrogen will be your gas. Clear? And the last step of every chemical reaction or equation should be balanced. So I will talk about the balancing part, but here it need to be balanced. Zinc, 1 zinc, 2 chlorine, 1 chlorine. So simply I need to multiply 2. And it was already 2 hydrogen, here also 2 hydrogen. Another one, formation of precipitate. Clear? I am taking sodium sulfate, barium chloride. It's a kind of double displacement reaction. It will give rise to barium sulfate, and which is actually a precipitate. So instead of a PPT or precipitate, simply I can write down the downward arrow mark, this particular segment, and the remaining part will be your sodium chloride. Last step will be your balancing part. I hope this is clear. Okay, now coming to some of the tactics to balance the chemical equation. Sir, what should be known? Start with the compound containing the most atoms. Then you have to balance the elements that appear only on each side first. Next, balance the diatomic gases. The third point is highly essential. Remember that whenever you are going to see the diatoms, like, or the diatomic gases, oxygen, hydrogen, nitrogen, chlorine, do not write oxygen means only O. Do not write hydrogen means only H. O means O2, H means H2. This is the procedure to write any diatomic gases, because they are so light non-metals. That's why it's a representation to write in this particular way. Clear? Now, and then you have to ensure the coefficients are in the simplest whole number ratio. For example, I'm going to take another thing to understand the concept even better. I have taken iron, and iron is in which state? Metal means solid state. I have taken water, but in the condition of steam. Steam means gaseous state. Then it gives rise to Fe3O4, one of the iron oxide that is in solid state, and then hydrogen is in the gaseous state. How to balance? First check, remember that, first check which one you have taken in the reactant side, it is more in the product side or less for the metal category. And who is the metal here? Iron, right? And iron in the reactant side, only one iron is there, but in the right side how many? 3. So can I multiply 3? So right now 3 iron on the reactant side, so as well 3 iron in the product side. Clear? Now how many hydrogen in the reactant side? 2. This side also 2. But how many oxygen in the product side? 4. This side only 1. So can I multiply 4? It becomes 4 oxygen. Now ultimately, while I was balancing oxygen, hydrogen becomes 4 to the 8. So again I have to balance this hydrogen. So the new equation will become 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Okay, now remember that this is the node point, and never ever change the formula. Formula means the subscript of a substance. For example, H2O means it has to be H2O. Do not write H2O2, and that is actually a wrong concept. Students usually do the mistake like this, so you should not do this. Clear? Okay, so the next point you need to understand, ensure the coefficients are in the simplest whole number ratio. Clear? And most important line at here, the polyatomic ions like the sulfate or the nitrate or even phosphate also, like PO4 3-. Clear? And they can be balanced as a single unit. Remember that this is the most important point of this particular scenario. Whenever you talk about polyatomic ions, they always be represent in the single unit if they appear on both the sides. Sir, we didn't understand. Okay, no problem. I have taken one of the best example to understand the concept even better. Let's say I have taken magnesium phosphate, which is my Mg3PO4 whole twice, along with aluminum sulfate, Al2SO4 whole thrice. Now tell me what are the metals. Okay, so one metal is your magnesium, another one that is your aluminum. So far we have understood that from last couple of reaction, whenever any metals are with their polyatomic ions, they will exchange each other. That means the phosphate will transfer to aluminum and the sulfate will transfer to magnesium. I hope this is clear. That means it will gives rise to Mg3PO4 whole twice, this is your reactant particularly, and Al2SO4 whole thrice, and it will gives rise magnesium sulfate, and the formula goes MgSO4. Clear? Plus aluminum phosphate, that is AlPO4. The formula is like that. Now the last problem is basically balancing. How to balance? Already I have mentioned, when you talk about polyatomic ions, you have to balance in the case of single unit. That means SO4 will behave as 1, PO4 will behave also like 1. So how many PO4 in the reactant side? 2. But in the product side only 1. So I have to multiply the whole product by 2. Ultimately how many aluminum? 2 aluminum. Here also it was already 2 aluminum. No need to worry about it. Now coming to magnesium. How many magnesium in the product side? 1. But in the react side 3. So multiply 3. Ultimately how many sulfate it becomes? 3 sulfate. It was already 3 sulfate. So that was the point I wanted to make it clear. I hope you like this.